For 100 years, the radial-flux motor was the undisputed king of electric power. But today's multi-million-dollar hypercars are switching to a bizarre, flat pancake design called the axial-flux motor. Here is exactly how rearranging magnets change the physics of horsepower. And no, before anyone asks, this has nothing to do with the flux capacitor. Nobody is going back to 1955. Here is the part almost nobody mentions. The pancake motor is not new. It is the original. In September of 1821, Michael Faraday stood in a basement at the Royal Institution in London and made a wire spin around a magnet in a dish of mercury. That was the first electric motor. 10 years later, he built a machine where the magnetic field passed straight through a spinning copper disc, face to face along the axis of the shaft. Flat, disc-shaped, axial. Faraday's boss, Humphrey Davy, was reportedly so jealous of the achievement that the working relationship never really recovered. The first electric motor in history came with office politics attached. Then in 1889, Nikola Tesla filed United States patent number 405,858, which patent lawyers still cite today as the first axial flux machine. So the technology your favorite hypercar brand is calling revolutionary has a patent older than the internal combustion car industry itself. So why did we abandon it for a century? Because it was a nightmare to build. A radial motor is shaped like a soda can, a cylinder spinning inside another cylinder, with the magnetic field firing outward from the middle. That shape is beautifully easy to manufacture. You stamp thin sheets of steel, stack them into a tube, and wind copper wire around the outside. Machines have been doing exactly that since the 1890s. The axial motor is a stack of pancakes, discs facing discs. And when you put two powerful magnet discs either side of a copper disc, they do not politely hold position. They try to slam together with enormous force. Every bearing, every housing, every millimeter of clearance has to fight that attraction for the entire life of the motor. With the tooling and materials available in 1920, that was simply not worth the trouble. What changed was magnets, specifically neodymium magnets, which arrived in the 1980s and were strong enough to make the flat layout genuinely worth the engineering pain. So what does the pancake shape actually buy you? Think about pushing a merry-go-round. If you push near the middle, almost nothing happens. If you push at the outer rim, it swings around easily. Same effort, more leverage, more torque. A radial motor does its work close to the center of the shaft. An axial motor puts all of its magnets out at the widest edge of a disc, which is the equivalent of pushing at the rim. On top of that, the magnetic field has a much shorter path to travel, and the copper windings can be far tighter, so you waste less energy heating up wire that is not doing anything useful. You will hear people say that torque in an axial motor grows with the cube of the diameter, so it just crushes a conventional motor. That is only true if you pretend the motor never gets thicker. In reality, as the disc gets wider, the steel inside has to get thicker to carry the field. And most of that magical advantage quietly cancels itself out. Real motor engineers have been rolling their eyes at that claim for years. Which brings us to the numbers and to the single most misleading figure in the electric car world right now. In October of 2025, a British company called YASA announced a motor weighing 12.7 kilograms that produced 750 kilowatts. That is over 1,000 horsepower from something you could carry under one arm. Roughly 59 kilowatts per kilogram. That number went around the world. Here is what mostly did not. It is a prototype on a test bench. The figure has never been independently verified, and it is a short-term peak, not something the motor can actually sustain. YASA's own press release says continuous output is around 350 to 400 kilowatts. So the real keep doing it all day number is closer to a fifth of the headline. Production axial motors you can actually buy sit nearer 5 to 14 kilowatts per kilogram. That is still excellent. It is just not magic. And the cars are real. YASA motors are in the Ferrari SF90 Stradale, which in 2019 became arguably the first production car with an axial flux motor. They are also in the Ferrari 296, the Lamborghini Revuelto and Temerario, the McLaren Artura, and the Koenigsegg Regera. Mercedes liked the technology so much it simply bought the company in 2021. Koenigsegg went further and built its own. The dark matter motor weighs 39 kilograms, makes 800 horsepower, and is roughly the size and thickness of a robot vacuum cleaner. 800 horsepower from something shaped like a Roomba. And in August of 2025, a Mercedes concept car running 3 axial motors drove 24,901 miles at the Nardo test track in Italy in about 7.5 days. That is the circumference of the Earth, in a week. So why is your car not using one? Money. An axial motor currently costs somewhere around 25 to 40% more than an equivalent conventional one. The air gaps inside are under a millimeter, which means aerospace-grade tolerances on a car production line. It is genuinely difficult and genuinely expensive. And here is the detail that should keep everyone honest. Ferrari, the company that helped put the first axial motor into a production car, built its first full electric car with conventional radial motors instead. Lucid, Rimac, and the Lotus Evija are all radial too. Around 99% of every electric car on the road still uses the soda can, not the pancake. So the pancake motor is not conquering the world. It is doing something more interesting. It is finding the specific jobs where being flat, light, and absurdly dense matters more than being cheap. Hybrid supercars, aircraft, and now the first wave of high-performance electric cars from Mercedes-AMG. It only took about 200 years for the shape we started with to finally make sense. If you enjoyed this, there is more automotive history where that came from, and the comment section is where I get corrected, so have at it.